All right, so continuing on with 1.3, now we're looking at the limit of a function. So for a function f defined on an interval containing a constant c, and again, it doesn't always happen that c actually itself works, the limit of f as x approaches that c exists if and only if the limit of f of x as x approaches c from the left is equal to the limit of f of x as x approaches c from the right, and that's equal to some L, okay? Now then the limit is written as the limit of f of x as x approaches c. It doesn't matter if it's from the left or the right, those are equal. Then we get that's equal to L. Okay. Now when answering limit questions, only are concerned with where the output of the function is headed as the input gets close to a point, not whether the output actually ever arrives at that value. So, sometimes, on the case over here, as we went to the 6 from the left, it's going to negative infinity, and so that was what our limit was. Whereas this one, we actually hit a value of -1. So that's the key. It doesn't always have to arrive at that value. It's just headed in that direction. It gets very, very close. Now, as we saw also, a hole in the graph, that open circle may be the limit of the function at a given input event, though it can never arrive at that value. And that's what we had at the 0. So we had the limit going from the left and the limit going from the right, both equal to -1, which then what that tells us is that the limit of f of x as x approaches 0 from both the left and the right is equal to -1. Now it never reaches it because we don't have it equal to there, and so it can never reach it, and so that's going to be a key point. Okay, so that's what happens with those holes. So now let's go back to this, and we kind of just answered this one, the limit of f of x as x approaches 0. Well, from the left it equals -1, from the right it equals -1, and so that limit is -1. What about this one? Well, as we approach the 6 from the left, we go to negative infinity. As we approach 6 from the right, we get -1. And so because those are not equal, that does not exist. Okay, so they have to be equal. The limit from the left has to equal the limit from the right, and that has to equal a specific number. And then we can say that that limit exists. But because this one goes to negative infinity and 1, those are not equal. And so that limit actually does not exist. All right, so now we want to numerically estimate the limits. Show the numerical estimation tables with at least 4 estimates. Otherwise noted, start at point 1 away, either plus or minus. So if we're coming from left, we go a minus. If we come from right, it's going to be a plus. From the given input value, and then estimate the limit to the nearest integer. All right, so we are going to be approaching some 2 values. So we're going to approach it from the left, and we're going to approach that c from the right. So from the left, if we're going plus or minus 0.1, that means we're going to be 1.9. Now, if we're going from the right, that means it's going to be over, so that's going to give us a 2.1. So that's going to be our starting values. And then remember, we keep going by larger values, so then we'll get 1.99, and then we'll get 1.999, and then 1.9999. And over here, we'll get 2.1, and then we'll get, and so 2.1, and then the next one's going to be 2.01. I don't know why I put 1 there. And then 2.001, because we're getting closer and closer to that 2. Then 2.0001. Okay, and so now what we have to do is we have to plug those values into this function and see what we get for the output, and same with these. And so what I'm going to do now is move over to our calculator, and I better write these down before I start that. And so we have the, let me go back to that. We had the x squared minus 4 and x minus 2, and we're doing 1.9, 1.99, 1.999, and 1.9999, and 2.1, 2.01, 2.001, 2.0001. Okay, so now let's go to the calculator. That way I can get everything and then take it and record it back. And so now what we have to do is we're going to take the quantity, and we'll start with the 1.9, and we're going to square that, and then minus the 4, and then divide by, and then we'll have the 1.9 minus the 2. And so our first one will be 3.9. Now I'll go second enter, and now what I'm going to do is go back here, and I'll insert and put another 9. Then I'll come over here, and I'll insert and put another 9. And then I enter, so I'll get 3.99. And if we keep doing this, it's going to go 3.999, 3.9999, but we'll show how that actually works. We'll keep going here. So let's go ahead and put our 9 here first. And maybe it'll let me do that without having to do that. So as you can see, now we're at the 3.999. And again, the next one will have 4 9s. So I won't do that one. All right, so let's go back. And so let's go to, now we'll do 2.1. So 2.1, and then we'll put a 2.1 over here. And then we'll delete those. And now let's see what we get here. Here we get 4.1. And then when we do the second one, now we have to insert a 0 here. Now we have to insert the 0 here, and we get 4.01. And if we keep doing that, it's just going to add in more zeros. So the next one we do will be 2.001, and that should give us 4.001. So let's insert a 0. Insert our 0, and we get the 4.001. So, and like I said, that's going to continue on with the next one. So let's write these out. So the first one, we got 3.9, we got 3.99, we got 3.999, and we got 3.9999. And here we got 4.1, 4.01, 4.001, and 4.0001. Okay. So what does that tell us? Well, it looks like as we approach 2 from the left, we're going to approximately 4. And as we approach 2 from the right, we're going to approximately 4. And so to numerically estimate this limit, I'm going to say the limit of x squared minus 4 over x minus 2 as x approaches 2 is going to be approximately 4, because we're getting close to 4 as we go this way, or getting closer to 4 as we go this way. And so because we're going from the left and the right, then overall the limit is going to give us that 4. And so that would be the limit going left and right. All right, so let's do the next one. So the next one, we're going to start out 0.01 away from 2.5, and we're going again from the left and from the right. And so what we'll need to do is we'll need to go that 0.01 away. And so if we do that 0.01 away from 2.5 on the left, it's going to give us 2.49. Now we're going by 0.1, so then we'll get 2.499. Then 2.4999, and we'll get 2.49999. And from the right, so now it's going to be the 2.51, that's 1.01 away. Then we'll get 2.501, that extra one goes in here, 2.5001, and 2.50001, okay? And so now we're going to plug all those into the 3 to the x over 2x minus 5 in our calculator and see if we can get a nice pattern showing up. All right, so let's clear that. And so now we have the 3 to the x. Well, the first one's 2.49. Now we need to remember to take that down, divided by, and then we have 2 times 2.49 and then minus 5 in parentheses, and that gives us negative 770.90. Let's do 3 decimal places, so that would be a 7. Okay. Now let's add the next one. So now we have 2.49, oops, yeah, 9. And up here we'll have another 9. Okay. And so now we can hit enter, and now we get negative 7785.67. Let's go to 3B1. And as you notice, we don't have anything that's kind of nice here. So we're actually going to have to do all of these. So that'll be second insert another 9 here. And add another 9 there. And so that's going to give us a negative 77933.724. And then one last time, and we have insert a 9 all the way back. Oops. Put that 9 right there. Insert, and we have a negative 7794114.301. Okay. And so what it looks like it's doing is it looks like it's going to kind of a negative infinity. That would be my guess. As we keep going, I think it's getting larger and larger and probably going to go to negative infinity. All right, so now let's go the other way. So now we have 2.51. So let's delete the rest there. And over here, let's have 2.51, delete those. And so now we get 788.033. And now we go up here. Oops. And we add that 0 in here. Go over here. That's going to be a 0, 1. So that's 7802.796. And go one more time. Insert 0. And insert a 0. And so we get 77950.850. And then for our, our last one, add one more 0 in here. So we have that. Another 0. And we get 77943.1.426. Okay. All right, so those are going to be our values we type into our table over here. And so now let's recopy those. And so now we have on this one, negative 770.907, negative 7785.671, and negative 77933.724, and negative 7794114.301. And this one was 788.033 and 7802.796 and 7790.850 and 77943.1.426. So like I said, this one, it looks like it's going to approximately negative infinity. This one looks like it's going to approximately positive infinity. So what does that tell us about the limit here? So that means the limit of 3 to the x over 2x minus 5 as x approaches 2.5 does not exist. And why doesn't it exist? Because this does not equal this. Okay, in the previous one, those were the same, and it has to be the same going to the same direction. And so this one does not equal that, so we don't have a limit there. All right, so let's pause there and we'll do another set in a little bit.